Okay, so let's look at control systems. Going to give you an overview of what this is like. Okay, and so let's talk about what a control system is. It's just a device or a set of devices that are coordinated to execute a set of planned actions. Okay, this could be controllers, computers, robotic equipment, storage equipment, automated process lines. The control system is all those pieces working together. All right. Usually we think about the computers or the controllers. Love the outdated computers here in the picture. Thought you might like this. Okay, so a video game controller is one idea of a control system. Okay, so you put input into the game console, the Wii, the PlayStation, the Xbox, whichever it is, and output or data then is sent to the gaming console, and you get feedback on the screen. Right, that's one way to look at it. Okay, and so here's how a video game controller works. Look here at the bottom of the screen, you see there's input, it's processed, there's an output, and then there's a feedback loop. The process gives feedback, okay, and the process adjusts. It doesn't mean it corrects automatically, but it makes some kind of adjustment for it. So it might be that it stops or it turns on a warning line or something like that. Okay, it doesn't necessarily mean that it fixes the process. Alright, so here we have the input, you manipulate the device. The sensor's read that you manipulate, like on your Wii when you tilt it forward, the accelerometer, for cal racing. That's my favorite game on the Wii, one of them anyway. Okay, processing, it's read. The game responds with some output. There's feedback on the monitor. Okay. Music player, one of the very earliest iPods. I mean, you guys won't have any memory of that. But you can see you can, of course, turn the dial to give it input. It's going to process it. It's going to adjust the volume, and you're going to get the feedback through your speakers. Okay? So you're going to hear that feedback. The volume strength is increased. All right? So you can see that we've laid out that process in the typical closed loop process. Now it's important that you understand the difference between closed loop and open loop. Open loop is going to run no matter what. Okay? It might run on a timer, but that doesn't mean it's reacting to input from a sensor. Okay? It's just going to run a set length of time or until you turn it off. Right? Think about how many times you've seen somebody's sprinkler system running in the rain. It'll be a full-on monsoon outside and their sprinkler system will be running because it's an open loop system. It's just programmed to come on every morning at 7 a.m. no matter what. Okay? A closed loop system makes some kind of adjustment or some input from a system. A refrigerator light system, the switch, okay, on the refrigerator, when it is not pressed, it tells the refrigerator that the door is open and you should turn the light on. That is a closed loop. Open loop, no feedback. Closed loop, there is feedback. Okay? Alright, this is an example. I'm going to give you some information on flowcharting, okay? It is just a schematic representation of an algorithm or process. So it's a picture of what you want to happen. Okay, that's what a flowchart is. So this example says count from 1 to 10 by odd numbers. Okay, not my most brilliant move, because if you're going to count from 1 to something by odd numbers, you're not going to get to 10. That should be 11. Okay? Alright, so we start at the top here, and we have the input number 1. Okay, and you see it's this parallelogram shape. You're following the arrows. Okay, so we're going to display the number 1 because we want to show it. Now we want to count by odd numbers, so we're going to add 2. Then we come to this decision box. And decision boxes have to always say, is the number greater than or less than 10? Okay, is the number greater than 10? Well, it was 1 plus 2, that's 3. So no, that's not greater than 10, so I come out the no branch. I go back up here, and I'm going to display the number 3. I'm going to add 2. Now I've got 5. Up, gotta go around again. Display the 5, get 7, back around. Display the 7, add 2, that's 9. Up, go around again. Display the 9, add 2, that's 11. Is 11 greater than 10? Yes, and our program ends. Okay? Alright, now these are all the different symbols. You can label these on your handout if you want to. Start and end is the same shape. This can just be some kind of bubble looking shape for you. Okay? Then process is normally your traditional rectangle. Okay? And this parallelogram is input. Alright? Now, just let me tell you, when I draw a flowchart, I use 3 shapes and arrows. I use a start end, I use a rectangle for everything except the decision, and I use arrows. Okay? There's not going to be a test on what is the shape for a display. Okay? The point of flowcharting is to work on the process. So I hope that this gives you an idea of the symbols that are used. And the next video you're going to be able to watch is making a flowchart and what that thought process is like. Okay, so I encourage you to just take your time with this flowcharting and don't get caught up in minutia. What you want to do is really work on the thought process. It's going to really help you when you go to do programming of both robots and automation systems. Okay.